All right, great. Today's lesson, we're looking at coordinate geometry, right? And in this lesson, I'm going to be looking at ordered pairs, right? How we represent a point on a graph. Then we're going to move on to relations on a graph. So basically the equation of a line or the linear function, sometimes it's called. And then how we use that linear function now to create something called a table of values. And then I'm going to take this table of values here and we're going to plot it on a graph, right? And then I'm going to give you one or two to try on your own. All right, so let's get into the lesson. So first up, we're talking about ordered pairs, right? So ordered pairs are used to represent a point on a graph, right? The ordered pairs consist of two numbers. The first number, the leading number, is always the x coordinate, right? And the second number is always the y coordinate. So I listed some examples. There's 5, 2, there's minus 3, 1, and there's minus 2, minus 3. For 5, 2, 5 is the x coordinate. You can see that here. And 2 is the y coordinate. For minus 3, 1, minus 3 is the x coordinate and 1 is the y coordinate. For minus 2, minus 3, minus 2 is the x coordinate, minus 3 is the y coordinate. Now, can you identify the x and y coordinates from these following pairs that I've listed here? All right, give it a shot, right? And you could always refer to the example that I had above. Now that we know what ordered pairs are, how are they actually represented on the graph? Now, to represent them on the graph, we need to understand what the graph consists of. All right, so the graph consists of these perpendicular lines called axes. They actually call axes of references. You'd see I kind of made reference of them here. Let me see if I can just grab my line tool. So it's axes of reference, and there's the x and the y axis. Right now it's in the straightest line. We work with that. Right, so there's the y-axis. I'll just circle it here, and there's my x-axis. Right, they meet in the middle, perpendicular to each other, and forms this big T. Right, so another word for this graph is the Cartesian plane. Right, the x is the horizontal axis. It goes from left to right. The y goes up down is the vertical axis, and they're both numbered lines. Right. So the right hand side is towards the positive side. You'd see I have a positive here, right? So to the right on the x is positive. To the left on the x is negative. This is where we get into the negative region, right? To the top of the y-axis is positive. To the bottom is negative, all right? So why is that important? It helps us if we know which quadrant a point lies in, right, what the values would most likely be. So I'm using the same points from my previous example, A being 5, 2, B being minus 3, 1, right, and C being minus 2, minus 3, right, and we're going to plot those on the graph. So heading off with A has an x coordinate of 5, so I look for 5 on my x-axis, right? And then I look for 2 on my y-axis, right? And that point's supposed to line up, right, directly with the 5 and the 2. So that's how you plot the point there. So notice that it's in line with 5 on the x and it's in line with 2 on the y, right? And we could tell that this lies on the top right-hand quadrant because both values here are positive, yeah? Next up, we have B, which is minus 3, 1. Minus 3 on my x is right here. Minus positive 1 on my y is here. So it's always good to identify where those numbers are. And then if you just take a ruler, I use my arrow tool, and I just come across here, and then I come up here, we're going to find that point. You're going to be able to plot that point, right? Again, you could look at the coordinates. Minus 3, 1 tells me a story. It tells me that the x is on the negative side, it's to the left, and the y is positive. All right, so that means it's going to lie in this top left quadrant, right? So those coordinates can tell you a bit about where the point is going to be on the graph. And last, I have minus 2, minus 3, both negative, so we're looking at the bottom left quadrant of the graph, right? Again, all I need to do is just circle my minus 2, circle my minus 3, pull a little arrow or use your ruler, and you're going to find where you need to plot that point. Now, had I had another point that was, let's say, 2 minus 3, that would lie in this region here, right? Somewhere right around here. right? If we had to plot a point like that, right? Because it will tell us that's in the bottom right quadrant. So that's how we plot our graphs, right? I want to move on now to the relationships or the linear equations or linear functions that we use to draw graphs, I would say, right? So every graph shows the relation between two sets of numbers, right? It's the x coordinates or the set of x values, and the y coordinates, the set of y values. So all graphs is always a relationship between those two sets of values, as we saw with the ordered pairs before, right? Now what we do is we use these linear functions or equations to describe the relationship between the two sets, right? And I've given the general appearance or look of these formulas, right? So this is just general here. Y is equal to mx plus c, or sometimes it could just be f of x is equal to mx plus c, right? We'll get into what the m is a bit later on, but basically the values of x can be defined, and as we put values of x into these equations, they will spit out corresponding y values, right? So look at what I said here. It says that basically the function of the equation gives us the relationship between x and y. So if I put a x coordinate into the equation, it will spit out the corresponding y value, right? So once the set of x coordinates are clearly defined, once I know exactly what they are, I can just sub those into that equation or that function and get the corresponding y values. Why would I do that? Because it allows me to create this table of values, a nice ordered arrangement of x and y values that helps me to plot the points that we saw on the last page. So here's an example. So we're given the linear equation y is equal to 3x plus 5. And the domain for x is 1, 2, and 3. So it means that the set of x values is clearly defined. We're only looking at 1, 2, and 3. All right? We could find the corresponding y values by substitution. So when x is 1, when I drop 1 inside of there, I'm going to get 8. Right? Right? So when x comes in here, 3 1s are 3, 3 plus 5 is 8. Similarly, when x is 2, 3 2s are 6, 6 plus 5 is 11. When x is 3, we get 9 plus 5, which is 14. And that gives me these points here. You see the coordinates, same ordered pairs from the last page, right? I can use this now to create my table of values. And what do I do with the table of values? Well, if I just change my share, I'm going to go across to my graphing app, my graphing tool. Right? So when x was 1, y was 8. So you see a point appears on my graph there, right? I don't know if you can see it. Maybe I could just zoom my graph in a bit. Yep. Right. So that's that there. When x was 2, y was 11. And then when x was 3, y was 14. So where's my writing tools? I don't know if you can see this, but I can still see my values on my x at the bottom here. If you see the 1, so the 1 lines up with the 8, and then this is 2 here. I can probably just make this a bit smaller so you can see the entire graph. Right, bring it down a bit. So this is spot on 2. If you look at 2 here, let me use the arrow tool instead. There's the 2 there. You see the 2? Right? And that aligns with my 11 here, right? Dead on in the middle, 10, 11, 12, right? And then the last one, 3 and 14, right? Spot in the middle of 2 and 4. In the middle here is 3, and that aligns with 14. So we took that linear equation, we subbed the values of x into there, the 1, the 2, the 3, and we got corresponding y values. And that gave us these ordered pairs that I could actually plot on the graph. And it gives me a nice straight line as well as a linear function. Yeah. So let's go back to our whiteboard. So that's what we did with these, right? That's what it would look like. So now what you can probably do is try creating your own table of values, right? So just to recap, we looked at ordered pairs. Let me just get my typing tool out. just to recap, we looked at ordered pairs today, right? So you need to be able to identify what ordered pairs are. They're usually made up of X and Y values. The first value is my X coordinate. The second value is my Y coordinate. We looked at plotting points on the graph. Oops. Right, and we saw on the graph there's a horizontal axis called my x-axis. There's a vertical axis called my y-axis. Right, we saw that there was positive and negative regions in my graph. Right, what else we looked at? We looked at the linear equation, right, and how we could sub x values into the equation, right, to find corresponding y values. And what do we do with this? That allows us to a table of values to plot graphs. Whoops. Right, so I trust that this was kind of helpful and it helped you to understand the basics of coordinate geometry, which is identifying points on a graph, plotting them on a graph, identifying what a linear equation is, and how you could find corresponding values from the linear equation. Next time we'd look a bit more at the linear equation, so we talk about what the M and the C is inside of there and how we can use that to do some other things. All right, so I trust that you found this was helpful. All right, and look forward to more videos.